All right, so these notes cover dividing polynomials. So before we start with dividing polynomials, let's quickly review some vocabulary. When you divide, you have a dividend, a divisor, and the answer is called a quotient. So if you write it in this form, the dividend comes first, then the divisor, the answer is the quotient. If you write it in this form, like you're doing long division, the divisor is on the outside, the dividend is on the inside, and the quotient ends up on top. And here, as a fraction, the divisor is the denominator, the dividend is the numerator, and the quotient is, again, the answer. So first, dividing a polynomial by a monomial, so something with several terms divided by something with only one term. Let's first think of actually a similar and much easier problem. Or rather, the fact that if you have something like 3/4, you could, if you wanted to, split up the 3 as 3 separate 1/4. So the same principle is going to apply to this problem. We can split up the entire numerator and make this into several smaller fractions that are easier to deal with. So we have 6x to the 4th times y cubed over 3xy plus 12x to the 3rd y squared over 3xy minus 18x squared y over 3xy. And then from here, it's just simplifying these three separate fractions. So 6 divided by 3 gives us 2. X to the 4th divided by x, we can subtract the exponents to get x to the 3rd. Y to the 3rd divided by y by the same rule as y squared. There's the first one. The second one, 12 divided by 3 is 4. X cubed divided by x is x squared. Y squared divided by y is y. The last one, 18 divided by 3 is 6. X squared divided by x is just x. And y divided by y is 1. So we don't have to write it. So there's the answer to our first problem. So polynomial long division you would use if you have a polynomial divided by another polynomial. And it's called long division because it works very similarly to the long division algorithm you learn in 4th grade, I think. So start it out. We're going to set it up as long division. X squared plus 3x minus 40. So just like if you were doing long division, the goal is to find something that you would multiply x minus 5 by that equals x squared plus 3x minus 40. And we're going to break it up into chunks. So instead of trying to do the whole thing right away, we're just going to find what could we multiply x minus 5 by to get us close to x squared plus 3x. So really, we just want to look to eliminate the first term, the x squared. So I know if I multiply x minus 5 by x, so since I'm multiplying by x, I'm going to write it up here. Multiplying by x. And x minus 5 times x gives us x squared minus 5x. And just like in long division, we will subtract these. So x squared minus x squared is 0, and 3x minus negative 5x is positive 8x. And then we just bring down the minus 40. So what can we multiply x minus 5 by to get us 8x minus 40? And again, we really just want to look to eliminate this first term, the 8x. So x times 8 will give us 8x. So plus 8. So we have minus 8x. And then negative 5 times positive 8 is negative 40. And when we subtract these, 8x minus 8x is 0. Negative 40 minus negative 40. Again, we have the two negatives here to be careful with. So all of this comes out to 0. So what that means is we have a remainder of 0. That's our remainder. So the answer is x plus 8. And to check, just like if we were doing a regular division problem, this means that x minus 5 times x plus 8 should in fact equal x squared plus 3x minus 40. And it does. You could check that using polynomial multiplication. So this second example here, looks like it's going to be more complicated because the divisor is a quadratic instead of just a simple linear binomial. We'll start off the same way. So x squared minus 5x plus 6. And then write the dividend inside the division sign, division thing. Okay. Again, we really just want to look to eliminate this first term right away, and we'll leave the rest of it alone. So if you multiply x squared by just x, you end up with x cubed, and we'll eliminate that first part of the division problem. So since we're multiplying by x, I'm going to write it over here above the 9x. Kind of like in long division, you keep track of your place value. Here our different place values are the different exponents. So when we multiply this divisor by x, we get x cubed minus 5x squared plus 6x. And we're subtracting that whole thing. So the first one goes to 0. That's what we wanted. And then, again, careful with those double negatives. So we have negative 2x squared minus negative 5x squared. So really that comes out to positive 3x squared, because you end up adding. Negative 9x minus 6x is negative 15x. And then we just bring the 18 down. Really, because there was nothing, this was a 0 here. There was nothing to subtract. So now we need to find, or we need to try to eliminate this 3x squared using our divisor again. So if I multiply this x squared by 3, then I would eliminate the 3x squared. So I'm going to have a plus 3 up here. So x squared times 3 is 3x squared. Negative 5x times 3 is negative 15x. And 6 times 3 is positive 18. And remember, we're subtracting all of this. And, as luck would have it, this is exactly the same as this. So they're all going to end up subtracting to 0. So that's our remainder. which means that the quotient is x plus 3. And if you wanted to check, you could multiply x plus 3 by x cubed, no, by x squared minus 5x plus 6, your original divisor. And that should get you back to x cubed minus 2x squared minus 9x plus 18. All right, so this fourth example, I guess, is going to end up having a remainder. First thing we need to do is this 2 minus a, that's ugly and annoying to look at sometimes. So we're going to change it to negative a plus 2. So those are the same thing, and it will make our division algorithm work nicer. So first, to eliminate the a cubed, we would have to multiply negative a by negative a squared. And when we do that, negative a times negative a squared is positive a cubed. And we want it to be positive because we're subtracting. And 2 times negative a squared is minus 2a squared. So when we subtract this, the a cubes go to 0. And then we have 2a squared minus negative 2a squared. Again, double negatives. So that ends up as positive 4a squared. And bring the rest of it down. So now we want to look to eliminate this 4a squared. And to do that, we would need to multiply negative a by negative 4a. And when we do that, we get 4a squared. And then 2 times negative 4a is negative 8a. And again, it's all subtracted. So the 4a squareds go to 0. And then we have 4a minus negative 8a. So that ends up as adding, and you get 12a. And then we bring the minus 9 down. And last, we want to look to eliminate this 12a. So negative a times negative 12 gives us 12a, and 2 times negative 12 is minus 24. And we're subtracting this, of course. So the 12a's go to 0, and then negative 9 minus negative 24 is positive 15. So here we do have a remainder. We have a remainder of 15. So there's a few ways we could write this. We could just say that the answer is negative a squared minus 4a minus 12. And then remainder 15. Another way we could write this, and to figure out how this works, let's think of a simpler problem first. If we had 11 divided by 3, one way we could write that is the answer is 3 and then remainder of 2. 3 times 3 is 9, and then 9 plus 2 is 11. And then this also would equal 3 and 2/3, or 3 plus 2/3. So we have the remainder is the numerator, and the original divisor is the denominator. So using that same same idea, we could write our final answer to this problem as negative a squared minus 4a minus 12, and then plus, so our remainder is the numerator, and our original divisor of negative a plus 2, or 2 minus a, is our denominator. So this is how we could write our final answer to this problem. Again, this is just the remainder divided by the original divisor. And the way you would check your answer for this is you could multiply negative a plus 2 by this quotient at the top, and then you just have to add the remainder. And that would, if that equals the original dividend, then you did all your work correctly. So, moving on to page 2, we have this thing called synthetic division, which is a faster process, but only for dividing a polynomial by a binomial, meaning your divisor needs to only have 2 terms, x minus something, or x plus something. And the way this gets set up, so first, this is going to be a very abstract looking thing. The way you start writing it is you're going to put r over here in a little box, and then you're going to write out the coefficients. A, B, C, D. Leave yourself some space. And then over here is where your remainder is going to end up. So, look at an example. So notice, first of all, this minus r, here it becomes a positive r. So here, our divisor is x minus 4. So in my little box, I'm going to have a 4. And then I write out my coefficients. 2, negative 13, positive 26, negative 24. And then we're going to follow these steps on the side. So we wrote the coefficients of the dividend. We wrote the constant r in the box. In this case, r is positive 4. And the first coefficient, the 2, we just bring this straight down. Now, we're going to multiply that, the first coefficient, by r. So in this case, we get 2 times 4 is 8. And we write the product under the second coefficient. And then we're just going to repeat that so first, negative 13 plus 8 gives us negative 5. Now, we're going to repeat that process. Negative 5 times 4 is negative 20. Write it under the next coefficient. Then we add 26 and negative 20 to get positive 6. Again, 6 times 4 is 24. We add, and we get 0. So this last one, 0, that's our remainder. And the rest of it, so since we started with an x cubed, this 2 becomes a 2x squared minus 5x. And that's our quotient. Nice, right? And so the one last example. So first of all, the way I wrote this is kind of mean, but really this is saying this negative 1 exponent is saying that we have 3x to the 4th minus 5x cubed So having an exponent of -1 is really just saying that that part is the denominator, or the divisor. Now, in order to use synthetic division, we have to have a 1x, right? Synthetic division is only going to work when this first coefficient is a 1. So here it's a 3, so we actually need to do some manipulation here, and we're going to divide both parts of this fraction by 3. Which we're allowed to do because we're doing the same thing to the numerator and the denominator. So now, once we do that, we get x to the 4th minus 5/3 x cubed plus 1/3 x squared plus 7/3 x, all divided by 1x plus 1/3. So now we can go ahead and use our synthetic division algorithm. So in this case, since we have x plus 1/3, that means that r is equal to -1/3. So I put -1/3 here in the little box. And then I write out my coefficients of the new one. So those are 1, -5/3, 1/3, 7/3, and notice that there's no constant term. We still have to account for it. So we have one last coefficient, and it's a 0. I know the fractions make it look messy, but I promise it works out nice. So we bring down the 1. And then the same process as the first one. 1 times -1/3 is -1/3. And -5/3 plus -1/3 is, you just combine the numerators, which would be -6/3, which reduces to just -2. And repeat, -2 times -1/3, that's +2/3. 1/3 plus 2/3 is 1/2. 1 times -1/3 is -1/3. And then this is a 7. It looks like a 2. 7/3 minus 1/3 is 6/3, which is 2. And the last one, 2 times -1/3 is -2/3. And 0 minus 2/3 is -2/3. So -2/3 is our remainder. And then our quotient is, so this is a 1x cubed minus 2x squared plus x, or 1x, and then plus 2. And then we can add our remainder like we did on that example on the other page. So I have my remainder as the numerator. So minus 2/3, and then my original divisor is the denominator. And that would be the whole answer for this one. All right, so Polynomial division is a lot of steps and can get very tedious, but in a few classes we'll examine how this is actually a really useful trick, particularly synthetic division. Okay,